Okay, I'm doing a radical whiteboard practice video for you all today, and I hope that you all watch it, especially those of you who are struggling to do this. Now, one of your questions on your test is as easy as this. It is labeling the parts of a radical. So this is actually a radical symbol. I prefer that, but the people who created the test are just calling it the radical. So it's this, okay? The number that goes right here tells you the root, and it's the index number. This is called the radicand. That is what is up underneath the radical. The exponent of whatever is up underneath the radical, you'll have a box here. Your test has actually got all four of those in a drop-down menu there, and you just click the one that goes where it goes. Now, you can do this with your calculator. I did it like I taught you to begin with, where you factor down with the factoring tree to its prime factors. And it takes two of the same number to bring one number out. So you've got 2 3s and 2 2s. So I brought out a 2 and brought out a 3. That's 2 times 3, and I have left a 5. So it's 6 on the square root of 5. To use your calculator, the square root button is located right here. You'll hit it, and then you can put in 180 and then hit equals, and this calculator will simplify it for you. Now, it will not simplify cube roots, and it will not simplify a big row of square roots. So sometimes you have to put it in separately, and I'll show you when we get to one. So if you put this in your calculator, that's 13, and some of you have those memorized. That's just 13. This one, I did it how I taught you to begin with. I took the factoring tree and did it, but if you put that in the calculator, just put the 72 underneath the radical. The calculator will not do the variables. You have to know how to do that yourself. So that is 6 onto the square root of 2 for the numbers. For the variables, you have 3 x's and 4 y's, and it takes 2 to bring one of them out. So I'm bringing out 1x, a group 1x, and 1 is left inside. And I have 2 groups of 2 here, so that is my exponent, y squared, and it came out and none are left inside. Okay, cube root of 16, you have to know how to do this, and so you factor it out, and it takes 3 of the same number to bring one out, and you take this 2 and multiply by that 2, that is 4, onto the cube root of 2. All right, this one you can put in your calculator. Honestly, your calculator will do it. To do cube root, you want to hit Shift and then hit the square root button and then put -64 into the calculator, hit equals, and it will tell you that it is -4. So check those out and see if it's a perfect root. This one is a perfect root, so put it in your calculator to see. All right, this one, now, your calculator will not handle all this. So what you can do is just take square root, hit the 90, hit equals. It tells you that is 3 square roots of 10. Then when you put in square root of 80, it'll tell you that is 4 square roots of 5. And then you put like terms together. So +3 and -4 is -1. Now, if you don't trust yourself, you can always type that in. And this is how you type that in. So you'll go 3 square root, hit 5. Now, to get -4 square roots of 5, you have to hit that right. You have to scale right and come out from under the radical. And then go -4 square root 5. And then hit equals, and it'll tell you it's negative square root of 5. So you can use your calculator once you get it here to do it. Okay? The square root of 12 is 2 square roots of 3. The square root of 48 is 4 square roots of 3. Add them together, that's 6 square roots of 3. And then this one, your 2 like terms, you have to put like terms together. -3 and -10 is -13. +1 and -6 is -5 square roots of 5. And you can put that in the calculator even Just remember to scale right and come out from under the radical when you go from one radical to the next. All right, and then square root of 8 is 2 square roots of 2. Just put that in your calculator. You can't put it all. I don't think your calculator will handle all of it. But you can put square root of 8, hit equals. It'll tell you it's 2 square roots of 2. You can type this, hit equals. It'll tell you it's 6 square roots of 2. And then your like terms, of course, are the 2 square roots of 2 and the 6 square roots of 2, which is 8 square roots of 2. So negative 5 plus 8 square roots of 2. Now, it's a multiple choice question test, a lot of it, and they may have it written 8 square roots of 2 minus 5. That's okay. It's the same thing. It's just turned around. All right, square root of 64 is 8. 2 square roots of 75 is 10 square roots of 3. And then 3 square roots of 28 is negative 6 square roots of 7. And none of those are like, and since they're not like, you stop. All right, and then this one, you can honestly put that in your calculator just like it looks. You can do 2 square root 6. And this is what I mean. You cannot just go times. You have to toggle out. Scale right and come out from under that radical. Now you go times 7 square roots of 12 and hit equal. And it tells you that is 84 square roots of 2. All right, here you can do 15 times 2 square roots of 6, and the calculator will give you that is 6 under the square root of 10. And then you have to do your variables like normal. You have 3 x's, and it takes 2 to bring one out, so I'm bringing out an x, and 1 x stays inside. All right, rational or irrational. This is the square root of 36, and the square root of 36 is 6. Just because you see a radical sign does not mean that it is irrational. This is a perfect square and is 6, and that is rational. So pay attention to that on the test. Remember, rational numbers is anything that can be written as the ratio of 2 integers, meaning it can be written as a fraction. So you can put a 1 under this and you've got a fraction. So this is 6, it's rational. Is this rational or irrational? This is a terminating decimal, that is rational. I can write that as a fraction. This is a repeating decimal. See the 1, 5, 1, 5, 1, 5, that's repeating. It's rational. This is irrational. If you put square root of 10 in your calculator and you hit equals, it tells you that it's the square root of 10. And if there's a radical left, when you put it in the calculator to simplify, if there is a radical left, it's irrational. But just so you see it, you can hit your SD button and see. It fills up the calculator screen. It's not terminating. It just can't go any further because your calculator is a finite thing and you can't see the numbers that are out here floating in space. So it takes it as far as it can, and that's it. And there is no pattern to it. There's no pattern at all. No numbers are repeating, okay? And it's going on and on forever. So it's non-terminating and non-repeating. It doesn't do either of those. And if you get it off, if you take it off, you hit that SD button again, it'll take it to the square root of 10. So when you have something left over right there, that's irrational. The sum of 2 rational numbers is always rational. 3 plus 7, 10. 1/2 plus 2/3. That's going to be 7, 6. That is rational. So it doesn't matter 2 rational numbers. There are none out there that I can even think of that would become irrational. They're not. 2 rational numbers added together is always rational. 2 irrational numbers added together will always be irrational. The square root of 3 plus the square root of 2. That's going to always be irrational. It's simplified. It's as far as it'll go. You have an irrational. There's no such thing as 2 irrational numbers being added together and becoming rational. Now, the sum of an irrational number and a rational number will always be irrational. So 3 plus the square root of 2, you can't put that together. It won't magically become rational. It is irrational. And when you're doing sums, an irrational number will always trump the sum. Remember the example that I gave you about it having all the power? When I add an irrational with a rational number, it's going to be irrational. The sum is. The product of a rational number and a rational number is always rational. It will never be irrational. The product of a rational number and an irrational number is always irrational. It's the same sort of thing. It's the trump card. Okay, so if I have a rational with an irrational, it will always be irrational, no matter what. Because remember when we're multiplying, we multiply outside numbers with outside numbers and inside numbers with inside numbers. So, a rational number multiplied by an irrational number will give me an irrational answer every time. Okay, the product here's the one that you have to remember that's different. Okay, if I add two irrational numbers, I'm still going to get an irrational answer. But if I multiply them, and this is very important, remember all this stuff that I'm explaining to you. If I multiply an irrational number with an irrational number, it is sometimes rational and sometimes irrational. And I've put an example up here. The square root of 2 times the square root of 2. Both of those are irrational. But when I multiply them, I get square root of 4, and that's 2, which is rational. The square root of 2 times the square root of 3 will be the square root of 6, and that is irrational. So sometimes when I multiply two irrational numbers, I get a rational answer, and sometimes I get an irrational answer. If I multiply two different square roots together, remember, square roots are irrational. Okay, most of the time, unless it's the square root of 4. But anyway, even then, my answer will sometimes be rational and sometimes be irrational. Okay, if I multiply two different cube roots, it doesn't matter if it says square root or cube root, the answer is the same. It will sometimes be rational and sometimes be irrational. The product of 0.56 times the square root of 18. Put it in your calculator and see. 0.56 times the square root of 18 equals. You see that? You see that radical in the numerator? That's because it's irrational. Hit your SD button. You see it fill up the screen. It's irrational. It filled up the screen without repeating and without a pattern. Now here, this is from the first test of the year. You want to do 3 times 2 minus 4. This is in the place of x. So I put it in the place of x. 3 times 2 minus 4. 6 minus 4 is 2. Then I put 6 in the place of x. 3 times 6 is 18. Minus 4 is 14, and now I add them together. That is 16. And then when I do this one, I want to look at what answers are in the double shaded region. My double shaded region is here, in this place. That's where it's at, anywhere here. That's my double shaded region. So the 0.3 negative 1 is located here. 3 negative 1 is right here. Then, so that's an answer. It's in the double shaded region. 1, 4. Here is 1, 4. It's tricky. It's up here. It even sometimes fools your teacher if I'm not paying attention. This is in the single shaded region. It doesn't answer both of them. It's not an answer. Negative 2, negative 5. Here is negative 2, negative 5. And it's in the single shaded region. It's not an answer. 3, 1. 3, 1, look, it's on the line. You see that solid line? This solid line is part of the solution. Had that been on the dashed line, it would not be part of the solution. Because remember, solid line is part of the solution, dashed line is not. So that is an answer. And then 5, negative 3. 5, negative 3 is here. It's in the double shaded region. It's part of the answer. Thank you.